All financial support for this podcast comes from my patrons on patreon.com. If you'd like to join in with the patrons, please check out patreon.com/DarwinGrosse. That's DarwinGrosse. Now enjoy the podcast. Okay, today I get a chance to talk to somebody who I'm actually really excited to speak to. His name is Stephan Schmitt, and he is the brains behind Nonlinear Labs, who creates this like mind-boggling synth called the C15. But he has a long history that has been in my interest fold. He's one of the founders of Native Instruments. He has a long history of development work for people who work in the Reaktor world. And so, as a lot of people know, I have a lot of history in that world as well. So I'm very excited to get a chance to talk to Stephan. Hey, Stephan, how are you?
I'm fine. Thanks for having me in this interview.
Yeah, well, thank you so much for taking time out to do this. I appreciate it. We're getting a chance to talk on a Saturday morning for me, a Saturday evening for you, but I appreciate you take some of your personal time to have this discussion. For people who might not be aware of what Nonlinear Labs is, why don't we start off by having you explain a little bit about your company?
Yeah, Nonlinear Labs is a small company, also by intention. So we are 5 to 10 people. We are developing only one product, and it's a niche product in a way, because it's addressing musicians that are really into keyboard playing and expressive playing of keyboard instruments, and some unique features or some unique concepts that we have behind the whole thing. And of course it's based on experience from my past, so I bring in experience with software instruments. And it is a hardware instrument that we are building now. It is just like a dedicated, self-contained instrument that is not meant to be the universal, let's say, workstation, but something with a real character. So very old-school instrument building. This is our instrument manufacturing. This is what we try to do here. We also try to work with local companies or with European companies mainly. We try to be also in direct contact with our customers. Mm-hmm. So we do direct sales. This is ending up, okay, it's not a very, say, low-cost product. It's more on the pricier side. Also because we are a German company producing locally, assembling the thing at our place here, and dealing with the customers directly, so taking really care about the users, giving them a training and so on. So it's, I can say, kind of the opposite of what I have done before.
Yeah.
So it's something, it's a passion thing for me. Right. So the product is very much defined by my own, let's say, preferences and ideas. And that's why, it is also it's a niche thing. So my personal preferences, I'm not sharing, say, with the mass market. It's more like some musicians who have a similar idea of what is the quality of an instrument.
Right. I remember the first time that you showed this at a NAMM show. I was talking to a friend of mine, and I was like, "What did you see at the NAMM show that like amazed you the most?" And this is a guy who's pretty jaded, so he doesn't get amazed very much. And he was like, "I saw the Nonlinear Labs C15, and I can't tell if it's brilliant or crazy because first of all, he said, when I touch it, it seems amazing that the things that you've done to make it feel expressive, blew him away. But he's like, but also it's like oriented toward keyboard players instead of like MIDI producers. And he's like, I don't even know if there are enough keyboard players left to be able to enjoy something like this.
Exactly. This is our risk. Let's say we are addressing buyers who are maybe, let's say, the number of buyers getting smaller and smaller,
right.
potential. But on the other hand, I feel it like, for me, it's a statement. It's also kind of a mission, and I try to also to convince young people that playing live, playing in real time, and playing expressively is really worth to learn and to invest time.
Right.
Because the most valuable thing is time that you have to invest. And I would like, for example, to convince jazz players, and there are many young, say, piano players and so,
right,
to try to go the electronic way of sound, not in the electronic way of producing, but just the sound creation, or the sound engine being a digital electronic thing.
Right.
This fascination has been, let's say, in the 70s, 80s, with people like Herbie Hancock and Chick Corea and so on. They brought, or they explored all the possibilities of electronic equipment and instruments, or Joe Zawinul and so on. But today, the jazz scene is very conservative, but I'm on a mission, to convince these, for example, these sort of people. And also, when we came to NAMM show, we really enjoyed to meet a lot of good players, mainly from the black scene, the black music scene, and they also love the instrument. So it's this field of, let's say, also funk music, soul music, neo soul, and so where the instrument really fits into, and I think this will not die.
Yeah, well, I think that you're onto something, and the fact of the matter is, I think that people have gotten this vision that all music comes from sample CDs and goes through a DAW in order to be made. But when you actually talk to people, especially in the hip hop scene right now, there is this real resurgence to have a group in the studio jamming and doing a great funk track to build a hip hop track off of, right? Or you have bands like the Roots and some of these others that are just that are really pushing again the idea of what live musicianship actually brings to the enjoyment of music. And I think it's really interesting. I also love this idea that you're on a mission to sort of reestablish electronic sound stuff into jazz. I agree with you. I mean, it's like it used to be that the most amazing explorations in electronic sound were Zawinul and Hancock and Korea, and where these people were taking the instrument, far more than, commercial designers or rock music was. It was the jazz guys that were really pushing the envelope, and it seems like trying to find a way to encourage that world to take on electronic sounds again is a pretty neat goal.
For me, it's kind of an experiment. It surprises a lot of people that I bring an instrument to the market that is electronic, and it's not designed primarily for the electronic music or the styles but it works like a natural or a classical instrument. And then comes this discussion that we omit MIDI. We don't have MIDI implemented,
right?
Which is trying to focus on this domain of live playing, of having a very, expressive and sensitive keyboard, and to make the best out of that, so that the engine is responsive. It's about the response to the real-time playing, and so we are in the domain of, let's say, instrument building, like nearly all the others, except the synthesizer makers. The guitar makers, the drum makers, and so on, even or the piano makers. Also, I mean, we are. It's about the outer side of the instrument. It's we try to get it covered. Well, we have it covered completely with wood, so it's also an organic touch that you get from the thing, and some maybe it looks a little bit too much like a furniture thing, but because it can be really let's say an angry beast. It doesn't sound like furniture.
Yeah, right. You're right. With the wood on it, it looks like it would be a very mellow thing. And then when I looked at at the synth engine, I mean, you're talking about a system that has sort of like wave shaping in sort of like the core of its being. I'm like, I have a feeling that this is going to sound pretty ripping.
yeah. We showed it to a composer in Hollywood, and he also said, "Oh, this sounds different than it looks."
Yeah, right.
Really,
yeah, no doubt.
Yeah.
So one of the things that I like doing on my podcast is talking to people about their background and how they got to be the creators that they are. And in your case, you have a very interesting background because you come at this hardware synth development from very much a software background. And so I'm kind of curious about what that path looked like for you, how you got started, where your interest in synths came from in the first place, how you got started working on digital synthesis, how you worked your way into and through the native instruments world, and how you came out of it to needing to do a hardware instrument. I'm really curious about this path. Could you tell me a little bit about that?
Yeah. Okay. So I'm now in the age of 62. So my young years, when I was a boy, it was in the 60s and 70s. In those days, I was very much into technology or technical tinkering. So,
right. Yes, tinkering. Yeah,
small
absolutely.
Project.
Yeah.
And I got some components for electronic circuits and some books around that. And so everything that I soldered and tried out was, for me, was fascinating when it produced sound. So it was.
Okay.
This was a very. I mean, the main goal, even when I was 12 years old, 10 years old, and I was doing something, I was interested how I can make this thing sound. And so I learned about electronics as much as I could get there and information. And later I started studying electrical engineering. So in 76 I started studying it in Braunschweig, a big technical university.
Okay.
And this, in the first place, doesn't have to do with audio and acoustics and stuff like that. It was really serious, say, engineering from the energy and or radio transmission stuff or whatever, everything that is electrical. Say at the same time during studies, I was also a member of some bands. So I was fascinated by rock music and jazz rock also, and later also some world music, so working with African people also. In these bands, I was the keyboard player. I didn't have a good education as a keyboardist, so I had some lessons on the piano when I was young. But this is, until today, this is my big, let's say, a thing that I miss. I try to compensate.
Right.
is to be a better player. Actually, currently I'm taking piano lessons again and trying to really to improve.
Okay.
But I was coming of course from the technical side, and I had there some knowledge I could apply in the bands. I was also doing sound reinforcement stuff, live mixing, studios stuff for bands. So I was always on this on the border between technical and musical, say, activities.
Mm-hmm.
It was taking up a lot of time. So my studies was suffering.
Yeah.
And it took quite long until I finished study. So in '88 I finished, and I started a job in Berlin. So this is how I came into the city where I'm still living. I started in the communications industry, developing or being a member of a development team for fiber optics transmission.
Yes, right, okay.
I was always more like the analog guy. So fiber optics is at very high speeds, but then it's analog again. Yeah? So you're dealing with photodiodes and stuff like that. That is where the signal and the noise. Yeah, you have to get the maximum out of this. Yeah, so the maximum of signal and the minimum of noise. So that was my first job in Berlin. I was there for 2 or 3 years, but in this time I was still very much fascinated by music and also by digital instruments, or by actually all kind of instruments. But this was the time of the DX7.
Ah, okay.
And as somebody with a, let's say, electrical engineering background, the DX7 was not so scary for me like for others.
Right.
And I had quite a number of synthesizers and keyboards when I was a student. I sold them all. For a while, I bought CP70s, the piano, Yamaha grand piano. This was like, I thought, okay, to be serious about music means playing piano, and piano is enough. Don't be so distracted by all this technical stuff. So, so this piano, but this phase with the piano was, I learned that, okay, I will never become a relevant piano player. And what I was more able was, of course, electronics and, let's say signal theory stuff. Mm-hmm. And that's why I had decided for the DX7 around the end of my studies. And then when I was living in Berlin, I was playing the DX7 only. I was trying to find my own style, my own way to play it. I made some solo concerts with improvisations on the DX7 and some effect devices. And this was for very small audience, like in galleries, and so the artist environment, not so much the commercial music environment. Mm-hmm. And by this, I found some contact with dancers, and they hired me to make the music and play with them when they had a dance. So it was modern dance stuff. And so I got quite some stage experience by this, but in a very, let's say, experimental and, let's say, non-mainstream sort of music. But I quit my job to spend more time on music. After a while, of course, the money was used up, and I got another job which was really a nice fit for me. They offered me to join a team that was developing mixing consoles, and the special thing was it was people from East Germany, because in 1990, when the wall was down and Berlin was reunited, and so the Western companies were looking, okay, what are the qualified people in the East and qualified interesting projects in the East, and so one company was interested in this team that had developed all the audio equipment for the East German broadcasting system.
Right.
And so they had a computer-controlled mixing system, not finished, but in development. And so I was hired to join them. And so this was a very exciting time to develop a monster mixing console with people from the East, also to learn about the East German history and way of thinking, and by the way, brilliant engineers, because they had to work with much weaker components than we had available. So they had to really to make things work which are nearly impossible, and they make the impossible possible,
Yeah, kind of magical engineering, right?
Yeah, and so in this time, because it was a computer-controlled analog mixing system, I had to deal with a lot of also with software components, and so my colleagues in the software domain, they got input from me because I was leading the project, and I had to specify it, and we had to test it, and so on. So I got more and more in touch with software. For me, it was clear that also audio it was already going in this direction. It would be software more and more. So I got, I thought, okay, I have to train myself to become also a software developer, because I was mainly an analog
hardware engineer. Yeah, right.
Yeah, a developer. And I met one guy. Actually, he was he was just a student, internal also. He was also into music, and when we talked about it, he was interested in joining a project that I was imagining. This was okay. Let's learn how to make sound sources in software. Because this is the most exciting thing. Sound processing, like with effects or with mixers, it's not the source; it's just a later stage, and you can finish the product, or you can make it sound well. But the most exciting aspect is where the sound comes from. So where the oscillation starts, so where the waveform is created.
Right.
The software project was. Also, after 2.5 years or so, it was cancelled because the money was cut down, and political situation. So I don't know. Actually, today I would say it was a monster project that didn't have a big chance to survive a long time.
Right.
Of course, lots of experience in development for all of us involved there. This project ended, and I convinced this German colleague to start a little project on our own at home to find out if we can develop something like synthesizers, just as software project. And there was at that moment still not the power of the desktop computers or notebook computers. Not to think about notebook computers. The power of desktop computers was not sufficient to get, let's say, more than maybe one channel of effect or like a stereo effect chain, working. So we first started with a DSP system. So said, okay, we have the full freedom of the software design, and so we can do this on DSPs. Maybe later we can do this also on main processors, on native processors.
Right. And
actually, this was quite soon the case. So Windows 95 was available. So it was a 32-bit operating system. The Pentium 5 was out, which was also a powerful processor. I think Dave Smith had some influence on some small aspects for signal processing there, because Intel was also trying to position this processor because it was so powerful, also for real-time calculations, in the field of audio, in the field of also modems of those days, and so to move some of the, let's say, peripherals, like sound cards and modems into the processor. This was the idea, and that was the name for native signal processing that they introduced, NSP. It didn't survive very long because I think the industry was not willing to follow them.
Right.
But with this, so I had this software library, or I had to look at the software library, and the name gave me also the idea for native instruments. Foundation later. So we forgot about we said we can forget about the DSP. Let's go for really native signal processing in the way that we use ordinary desktop computers, and the law of Moore, telling that the processing power is doubling. It was true for a long time. It became true. So Intel and these hardware companies, they worked for us in the way that they made our creations more and more powerful.
Possible, yeah, right.
Guarantee with the guarantee, that it's after 2 years, and we're a little startup. In those days, there were no startups, so we needed some time to learn and to find out how we can create this. And when we were at the market, the processors and the systems were fast enough to create a convincing instrument.
Right.
This was 96. We showed the first the first version of Generator, which was the predecessor of Reaktor. We showed this at Musikmesse, the German, the big German trade show.
Right.
And we got some press, which was taking it in the way that I was also excited about. I thought, okay, this is the next big thing, software synthesis,
Right.
So I was very much also promoting the advantages of software synthesis and the flexibility, that you get user interfaces, graphical user interfaces, complete freedom there, full integration into sequencers, and so on and so on. And the biggest argument, of course, is price. Yeah, so you get instrument, or you can create instruments with a quality that was not affordable in hardware for maybe 50, 100, or 200 euros for a plugin.
Yeah.
And this is still today. This is of course, this is a big factor that you can save so much, or you can create really serious serious sound sources for small money.
Right.
So this trade show '96 gave us some publicity. So the press was they were giving us some space there, telling this is the most exciting or most interesting thing, upcoming thing. And by this, some people noticed us and they asked us to join us. So it was we were able to build up a team with people who were even more qualified in the software development domain than we were. And so this was the start for Native Instruments. So '96 is also this was the first official year for Native Instruments. And in the beginning there were two people, this colleague and me, and then 1 year later we were around 7 people who became also the founding shareholders later of this
of the company.
Company.
Well, this is really an amazing story because you were actually one of the people responsible for what I think is one of the most important pushes in musical software development. About the time that you started was also about the time that the VST plugin environment was put out there, and the problem at the time to me was that the quality of the software-based instruments did not compare with the hardware equivalents. Right? It was fascinating to see things that would work solely inside of your computer, but the sound was not anywhere near expectation. And I was in a lucky position to work at a magazine that was I was writing for a magazine, and we got a copy of Generator in for a review. And I remember the first time I fired it up and made a very simple software synth, I remarked to my editor at the time that this was one of the first things I'd heard on the computer that actually sounded like an instrument that I would want to use. And subsequently, all of that kind of work on making good sounding stuff not only led to Generator becoming Reaktor, becoming this great software synth development system, but all of that technology was also used for things like the original the B4 and the P5 and some of these earlier emulation synths that were head and shoulders sonically improvements over any of the software instruments that have been previously available.
Yeah, Reaktor is, in the beginning, I thought that would be our only product. Because I had this idea of having the universal, let's say, construction kit for also empowering people that they can build their own instruments. But this is, of course, expecting too much from the users, and so we had to learn that offering something that as a developer who's developing software, it's good to be modular in a way, to have modularity and to recombine your components and to make them reusable. So I wanted to give this provide this also on the user interface, because I thought, okay, people can do this themselves. Let's them make their own instruments.
Right.
And this was an illusion in some ways. So the most successful products of Native Instruments were the compact instruments, or the ready-built instruments,
the pre-built,
the before and the pre-built instruments. And then, of course, you have also other possibilities to optimize the DSP and also the user interface. Have a dedicated, concept like an organ or a synth or a sampler or whatever. But in the beginning, it was Reaktor. What was the big use of Reaktor then, or how useful it was? It was as a development tool. Yeah? We benefited very much from having a system where you can develop very fast, something that sounds okay, and if you invest a bit more time, it sounds really good.
Right.
We had with Reaktor Core, we had access to every operations. So you can. The question of sound is only a question of know-how.
Yeah.
So you can do low-level programming as you would write a program in C, and so it was attracting some very good instrument designers. So we had people joining first in the community of Reaktor users, where we also had established a forum and a place for exchanging the creations. We met some very talented people there, who became part of Native Instruments later, developing instruments like Massive and so.
Right.
And doing this typically in Reaktor as the tool for prototyping and developing.
Yeah, I was involved with Native Instruments in some of the early days. I helped write the manual for the B4, and I helped with the P5 manual and stuff. And I remember that for helping with writing with the manual, the test devices I would get were actually like customized versions of Reaktor that had like the organ voicings and stuff like that. It was very much that system was used as your internal development system as well, right?
It could be also a development system, let's say, for third party, but Native never established, let's say, kind of a marketplace or so for that.
Right.
But we had the idea to have it also, let's say, for third party developer as, let's say, the platform. They could create their instruments and also make their own business on that. Yeah,
although I think that the way that you did the patch exchange system for Reaktor was one of the real successes with the Reaktor platform, was having this huge shared library that people could create things for. And I've known a number of people over the years that were Reaktor users that primarily spent their time sort of like surfing through the library of shared patches looking for new stuff, right? That was kind of like the constant area of exploration for them. They didn't really program. They mostly just kind of surfed other people's programming, but a very powerful system. Now, in addition to, the potential for people doing sharing and some of this other stuff, you also were involved in creating some Reaktor-based synths that were sold as instruments, things like Spark and Prism and Skanner. I think a lot of people will have good memories of working with those systems as well. What compelled you to do those instruments?
Yeah, it was. I tried also to get back to make music myself. So I had the problem over many years that I was so much involved with music technology that I was not able to make any music anymore because I would always think about the tools instead of the music, and about, let's say, bug fixing or improvements or what is in the mind of a developer. But I was able, after a while, when the company was running well, to spend more time with music. And I was creating my own, say, instruments. I had a MIDI keyboard, master keyboard, and a notebook in the rehearsal room. And I was trying to make mainly music, but on the other hand, of course, creating instruments that make sense in my, say, musical application. And that's Bach was one thing that was developed in this way. And
literally just from you playing around in your rehearsal room?
Yeah, I mean, playing and playing and testing the thing. So when you play with guitar players, for example, or with drummers, you notice, okay, how well the thing is, let's say standing up against that, yeah. And so and also spending many hours on just say modifying. So I started a concept that's I don't know, for example, for the Kontour, which later became the C15 sound engine. I started with a 4-operator FM structure, and I combined this with some filtering and with some distortion and wave shaping stuff. And then I tried to keep this all, so I don't want it to be the universal thing with thousands of parameters. It should fit on one screen, should be usable and easy to access for me, and therefore I try to keep it minimalistic in a way. Okay. Also, the 4-operator FM became a 2-operator, but while 2 of the FM operators became 0 hertz, so they became shapers. Okay. And then I learned more about the comp filter or how to work with comp filters. With Prism, we worked on modal synthesis. But combining FM and comp filters, for example, was quite effective and worked out well. And that's the reason why I was using, let's say, the predecessor of Kontour, which was called Phase 22, right? Yeah, phase modulation. Okay. 2 oscillators, 2 filters or something.
Oh, okay, got it.
It was something that it was a thing of evolution, you know. I had this for years already in, I don't know, hundreds of different versions. And then a colleague he was the lead of sound design at Native. He asked me, maybe you can share this with us and we can make a product out of it. And this happened several times. And so we produced some of these products. They are, in a way, they are similar. They are also Skanner. I mean, it's based on samples, but reading samples and with a sine wave. Something really special, and it has a characteristic sound. It's not something that works like a universal tool. Right. Prism has this, let's say, this very physical and metallic sounding character.
Again, not a universal tool, right?
No. And and Kontour, in the end, the last thing that I did for Native when I already had started Nonlinear Labs. Okay. It's a smaller and, let's say, version of what we have now in the C15, and it's has this the same concepts, like how to get metallic sound, how to get percussive sounds, how to get let's say, a lot of influence of the velocity, which is one of the main, let's say, modulation or expressive parameters, and how to make it work for real-time control with pedals and rhythms and whatever you aftertouch. I'm grateful that I could build this instruments based on Reaktor, and being like a evolutionary path to what we can offer today.
Sure. So let's talk a little bit about the design of the C15, because again, this is one that people who've experienced it have been pretty shocked by it. If you go read reviews that people have written about it, inevitably what they talk about is sort of like the surprising level of variety and sound that can come out of something that on the surface might seem like a simple system design, but it's one that kind of has a lot of built-in complexity, because you have this kind of FM-ish based system with a shaper built in, but also heavily focused on kind of there being a feedback circuit in the whole instrument design. It seems like when I look at like the engine circuit diagram, one of the things that I see is sort of like this: the whole top of the diagram is all the stuff that's part of the feedback system, right? And so feedback is clearly, and I think one of the things that anybody who's into media art, and especially the technology of media, kind of knows is that feedback is where a lot of magic lies, right? There's always something magical that occurs when you allow feedback to be part of the system. So in the design of this system, it's interesting that you talked about in your background, you had this transition where you went from the CP70 to the DX7, right? And then that became kind of the place where you found your electronic voice. You were doing these kind of solo concerts and being kind of experimental. And then when we talk about some of the things that you did in the later years with Native, kind of really exploring these metallic and these more aggressive tones, it strikes me that you have kind of a special place in your heart for sort of the combination of FM and interesting feedback-based circuits and all this kind of stuff. How did that inform the C15? I mean, did you come into it experimenting, or did you kind of know this is the engine that I want to explore?
I had the luck to try out, of course, a lot of designs and to work with a lot of very talented product and instrument designers. So I had, of course, the market already has provided a lot of choices, let's say, but that you can try out, like what Yamaha did for FM. Right. Korg did something in the domain also of physical modeling with the Prophecy and Z1. Or the Oasis system, or the Wave Drum, by the way, one of the really very interesting products.
Right.
And so I was always looking for systems that have their own logic and which have a small number of components and small, let's say, information built in. I don't like when instruments come with samples built in, for example, when they come with sequences built in. I don't want anything to be pre-defined and pre-recorded or pre-produced. I want that the sound is generated in the millisecond where you hit the key.
Yeah, okay.
And it's fascinating to see how complex FM can get with only a few sine waves involved, because of that say complex partials that it breaks up into. And it's also fascinating to see how complex something can get if you have a simple, if you have a delay, a feedback path, and a nonlinearity. So it's something that was also explored by the chaos theory. So with showing how a system can get chaotic if you think it's it's a very predictable, simple system that you're dealing with. Only a few variables in there, a few simple formulas, and you end up with a chaotic behavior that cannot be predicted anymore. So that's fascinating for me to have a structure. In our case, it's 2 sine wave oscillators and 2 filters, and some routing that you can crossfade and mix to make up output mixing passes, but also feedback mixing passes. Right. And we can create in the C15. We can create on the exciter side. We can create something like a noise, a short burst. And on the resonator side, we have a delay-based comp filter that, when you excite it, it already can create a rich tonal sound if you want, and you can play it because it's precisely tunable, and so you have also. Yeah, this is not invented by us, but it's something that's very effective also. Yeah.
Well, I think that's fascinating because I think that comb filters, people really think of comb filters as being a very small case thing, right? You'll use it occasionally for doing like resonant chords or whatever, but I think people don't think of it as having the potential for being a general use tool. And I love the fact that you have kind of brought this comb filter in as kind of part of the heart of the sound engine of the C15. Yeah.
I mean, you can run the C15 in different, let's say, configurations. If you can use only the oscillator, so you can run it subtractive as a subtractive engine. But for me also, it's the heart is the comb filter because you get these resonances. If you combine this with an all pass, you get also non-harmonic content there.
Right.
And when it comes to self-exciting, so by feedback loops, you get into a behavior that can be really surprising. Yeah? So feedback, not only like say classical, let's say, what you know from guitar feedbacks or so, but it's just how energy is coming back into the input of the filter and how this is also changing sometimes slowly. It's really surprising as you think, okay, this is only, let's say, a short delay and the feedback. Why should that have such, let's say, evolving behavior? So it is also very interesting that you only have to detune one of the components a little bit and you get dramatic changes.
Right.
Yeah.
Well, that's probably something you learned a little bit too in working with the DX7. I know the first time I got a DX7 and I went down the rabbit hole of programming it, I too had a technical background, and so I wasn't that intimidated by it. But what I did notice is the way that very small parameter changes could have very huge effects on the output because, again, of the effect of both what FM does with subtle changes and what feedback does with subtle changes. It can really, small parameter changes can have extraordinary effects.
I mean, that's part of also expressiveness. Huh? I mean, with if you think about, say, assigning velocity to certain, let's say, components of a classical analog synth, it can change the sound, but it will not change so dramatically as it would do with the FM synthesizer, where the spectrum can be completely, let's say, break. Yeah, you can get from a very mellow to a very aggressive sound, and by just driving some or having some parameters driven a little bit higher. And that's also what happens in this combination of comb filter, feedback, and FM. That's something. I was a keyboard player in bands with guitar players, and these guitar players they had the big noise and the big drama and the big feedback thing on there. And I want to give the keyboard player something back.
Yeah, right. It's give them something to compete with that, right?
To compete. Yeah.
That's great. That's great. So the one thing that nobody's going to let me get away without asking is to talk about your decision not to include MIDI. I think it's a brave decision. I think it's one that firmly puts you in the position of making a niche instrument. To what extent did you do that so that you did not have to compromise the engine?
Yeah, that's one aspect. Is that MIDI is okay. Today there's MIDI 2.0, and we can talk about higher resolutions. But MIDI is a node protocol. It works very well in many cases. But when it comes, for example, to resolutions, also of velocity, it's not so satisfying.
Right.
But the main thing for me is that when you start to think about an instrument as a self-contained thing, it should sound rich and satisfying and inspiring by itself. When you include MIDI, you start to think about this controller, an expander, master keyboard functionality. You're building up a system that is, more like your studio being your instrument. This is what I hear often.
And then you're back. Then you're back looking at general case instruments again, right?
Yeah, you spend a lot of energy and time on getting this, to building up this system and this complex configuration. And I wanted something that is really not distracting, or to be really focused on playing, not to think too much about how this can be automated and so on. It's really it's about the focus of the user, and it was also about the focus of us as the maker of the instrument.
Of course, yeah.
To not to think about, okay, this could be also a nice expander, and we could offer a master keyboard functionality for something and so on. It's the challenge is to put something that people really love to play and they don't miss anything externally. Right. And they get lost. They hopefully get lost in the playing instead of getting lost in, let's say, studio wiring.
Studio wiring, right? Well, that's a beautiful concept, and I really can appreciate that. And again, when I look forward to hearing more players get the C15 under their fingers, because it strikes me that this is a real, it's an opportunity to open up a new kind of playing, instead of just always thinking of synthesizers being kind of a studio environment thing. Again, you can start also thinking about a synthesizer as being a live instrument. And you said something earlier that just really resonated to me, which is that the way that you're building the C15 is kind of like every other instrument in the world other than the synthesizer. You're building it as, and I think of, you're almost like building modern harpsichords or something, right? It's something for a particular flavor and a particular kind of player who's going to end up needing the thing that you're making. So I think that that's really cool. And I applaud you for doing that.
Yeah, thanks. I was it reminds me of the clarinet, the Hohner clarinet, for example. Yeah. It's also from the size and some elements, and also from some parts of the sound character that we have, being very, say, dynamic, percussive, aggressive,
yes,
if you want, and that's why I think we can address the black music scene, but actually not only. As I mentioned, jazz musicians and people in this domain, but we have quite a number of customers in the domain of film music. So composers,
right?
Typically, they are trained to play the piano, so they are not missing, let's say, the MIDI input. Right. And they love the colors that they can get, the special, fresh sort of sound that they can get out of this instrument. Also, we have electronic producers who often tend to record audio and work with audio loops and snippets. And so they get inspired by the C15 by playing something on it. They record everything, and later they cut out something, and they use this for for their production.
Yeah, so there's ways to fit it into the modern studio too, right? That's really a great point. So unfortunately, our time is up. In fact, we went quite a ways over, but I so enjoy talking to you about this, and I have like a million more questions that I wish we could get to. But before I let you go, I know that you just came out with sort of an update to the sound engine and some of the programmability of the C15. It was going to be shown at the Super Booth, but you ended up being in sort of like the Super Booth, the virtual Super Booth. You showed off a little bit of those capabilities. Can you talk a little bit about what that update represented, and then what you imagine to be like the next things that are likely to be likely to see an upgrade?
We were able to optimize our sound engine and operating system in the way that we get more voices and also get more flexibility. out of it, and this we use in the first update. Now we use providing a dual mode, which means we can split up the 24 voices into 2 times 12, which can be layered or split on the keyboard. So with the layering, of course, you get richer sounds, and also an easy way to do sound design by combining components.
Sure.
There was mono mode missing up to now, so we are providing mono modes for solo playing in the classical way. And we have quite a number of parameters added. Tremolo is available now, and the feedback system, especially in the layer mode, gets really some more options to route the signals from one voice to the other and back to the first voice. So it's really advanced feature.
Cross feedback, my goodness, yeah.
Cross feedback through voices, And so we expect this, and we already experience it like being a powerful addition now. There will be a further evolution of this engine, but we also think about completely different sound engines, because this product is meant to be sustainable. It means so the hardware can be the basis also for other DSP software running on it. We just have to replace the magnetic foils in future, and then it could support completely other set of parameters.
Oh, wow. That's interesting.
That's why it looks a little bit, let's say, confusing for people to say so many buttons and only one encoder knob. But these buttons are the way how to access the parameters, and they are laid out in a generic way, so it can support something maybe a completely other thing like an edited sound engine. So there are some ideas already in preparation, but as we are a small team, it will take some time before we come with the next, different engine.
Well, it sounds like a beautiful way to work, though, and I love the fact that you've built this thing from the ground up as kind of a platform for experiencing, the work that you're doing. But again, also the focus that you're bringing to it, I really love that, and I appreciate so much you sharing your vision with me and with the listeners. Thank you so much.
Thank you. It was very nice to talk to you.
Yeah, likewise. Okay, with that, then I will let you have the rest of your evening. Thank you.
Yeah, thank you. Goodbye.
Many thanks to Stephan for the great chat. It's really interesting to hear about the beginnings of Native Instruments and how they came from being just a simple group of guys making some stuff to the powerhouse that they are today. Also really interesting to hear about an instrument maker that really has a vision, a specific vision, and is going to follow it with the passion and heartfelt interest that Stephan is showing with the C15. If you have a chance, go over to Nonlinear Labs and check it out. It's really an amazing piece of work. I want to thank everyone for listening, for continuing to pass along the podcast to their friends, family, people that they know. I also want to thank everybody who has been a Patreon subscriber. We've gotten a number of new subscribers recently, and that's super helpful to the podcast. If you're interested in subscribing, please check out patreon.com/DarwinGross. I appreciate every single person that gets involved. If nothing else, jump over there. I do some public blog writing there as well. If nothing else, you'll be able to maybe find something interesting as well. Thank you so much for listening, and we'll catch you next time around. Bye.